Continuing on section 2.2 on vectors, this is practice problem number 7. Question 7 gives us two vectors to work with, vector v, which goes over 1 up 2, and finally along the z direction 3, and vector w with an x component of -1, y of 2, and a z of -3. And then it asks us to compute 5 things. The magnitude of v. It wants us to do two vector additions, once of vector v plus w and v minus w, and then finally two magnitudes, the magnitude of v plus w and the magnitude of v minus w. Okay, let's compute these. First, the magnitude of vector v. We get that just by using the distance formula on the components for vector v. So that would be 1 squared, which is 1, plus 2 squared is 4, plus 3 squared is 9, and it's the square root of all that. That, of course, would be the square root of 14. So that's the magnitude of vector v. Next, we want to find a vector, which is the sum of vector v plus vector w. So all we want to do is simply sum the coordinates in order and list it as a new vector. So this will be a new vector, not a scalar. It's not a magnitude. Okay, the x components add to 0. The y components add to 4. And the z components add to 0. So the sum of vectors v plus w would be a new vector, 0, 4, 0, which means it is a vector that runs along the y-axis and has a magnitude of 4. Okay, correspondingly, we want to compute v minus w. And of course, v minus w means to do the same sum we did here, except we're going to change the sign of all the w components because we're subtracting it. Once again, this will be a vector, not a magnitude. So it's going to be 1 minus a -1, that's 1 plus 1 or 2. It'll be 2 minus 2, that's 0. And it will be 3 minus a -3, that's 3 plus 3, which is 6. So v minus w forms a new vector which goes 2 in the x direction, 0 in the y direction, and 6 in the z direction. Okay, our last two are to compute distances, and again, these will be magnitudes of the vector v plus w. Well, right there are the components of v plus w, and I can see right away that it's already in a form where the magnitude is easy to see. So we don't have to really put this one through the distance formula. Its magnitude is 4. No square brackets because that is a scalar. Vector magnitudes are always numbers. Finally, v minus w is going to require a little bit of work. We're going to sum the square of the components along each direction. So that's the square root of 2 squared is 4, 0 squared is 0, and 6 squared is 36. That makes the square root of 40, which I can simplify as 2 square root of 10. So there it is, computing vector sums and vector magnitudes.